This video is part 8 of the video series on developing an automated Accu-Slice system. It's been a long path to develop this system, starting with developing an automated system using a stepper motor to slice boards on a bandsaw. Then I developed a second system to index the board being cut and slice boards to required thickness with an accuracy of better than plus or minus 0.02 of an inch. I then combined the two previous systems together to develop a system that not only permits the manual or semi-automated operation of the bandsaw and Accu-Slice system, but also permits the fully automated operation of the Accu-Slice system. In the previous video, that's video number 7, I developed a software to operate the fully automated Accu-Slice system. I used an Arduino Mega controller and wrote the software for its operation. In this previous video, we described the software in some detail in the event that any of our customers might want to make their own automated Accu-Slice system. Additional modifications and updates to the software are still being conducted, but the software program is available for anyone who requests it. In this video, I will fully assemble the electronics controller, debug it, and then test the operation of this system on the bandsaw. Finally, I'll operate the fully automated Accu-Slice system to slice multiple boards on the bandsaw with no operator input, producing a fully automated bandsaw operation. Some additional videos are planned in the near future using this automated Accu-Slice system to slice boards and segmented discs for these projects. Well, I'm milling out the holes for my panels and my push buttons and LEDs on my front panel, which I just finished. I'm ready to do the back panel. I had to put my receptacle and switch in, and I need some other receptacles for my stepper motor cords and my limit switches, and also my Hall limit switches. So I got to drill those. I like doing it in a mill because it's accurate. As you can see here, these holes are all perfectly aligned. They're nice and straight. They're nice and clean. Not a lot of burr marks on it. This works much better doing it on my mill. So I'm ready to cut the slot for this switch, the combination plug and a switch on the back panel. And I have it all drawn out on the back, ready to go. Okay, next I'm drilling the holes for these electrical transfer pieces, and there's 6 of them. So I said I have my 2 panels done now. Now I can start assembling the system. Well, I'm ready to assemble these front and back panels, and I did cut these on the milling machine. And the reason I cut them on the milling machine because all the ones, like my lines are perfectly lined in a straight line, equally distanced, and I got nice clean cuts on the mill, which I can't do that good of a cut on the drill press. But before I even started, I did draw these up on the computer to get my layout and determine exactly where I want to put my holes. So I did that in advance. And then also for this front panel, I took that same drawing and I printed out these sheets. These are on a contact paper, and I can glue this to the front, and I have a pre-labeled sheet, so that's what the plan is. Unfortunately, this panel is more than 11 inches wide, so a full sheet was a little bit too small, so I had to do things a little bit different here. So I marked where I want to put it, and this stuff has a backing on it, which I can take one piece off. I then attached all the labels to the panel, and after the labels are attached, I'll take an X-Acto knife and cut the holes out for the push buttons and other components that need to go on the panels. Then the next step is to insert the push buttons and clamp them in place with the screws that come with them. I will finish it off. then onto the back. And that completes the back panel. So I have my front and back panels all assembled. Now I'm ready to start wiring it up. Okay, I'm in the process of assembling the controller for this automated Accu-Slice system. And I have my front panel, which I showed designed in the past. And now it's all wired up. I have all my resistors for my LEDs on this panel here. And all the wires hooked up, ready to hook up to the Arduino board. And in my main box here, I have my power supply. I have my 2 stepper motors, my Arduino board. I also have 2 small fans mounted on the back panel, a terminal strip. I have a power supply that converts 24 volts into 9 volts to run my Arduino program, and I have a relay to run my electromagnets. So this is pretty much everything installed in a box ready for wiring now. I have my back panel are all set up, and they're all wired for my inputs for my stepper motors, my Hall sensors, so that's all done. Power input, so it's all set up, my Arduino input. So the next thing is to install my panel and start wiring it up. A lot of wires here to hook up. So off camera now, I'll just continue wiring this up because it'll take me a while to get these wires all figured out and get them all cut to the right length so they're not no of a mess inside here. So let me go ahead and proceed to wire this up, and bring you back when I'm finished. Well, I just completed all the wiring. It's a little bit of a nightmare in there, but it's all hooked up. I double checked it all. I turned it all on. Everything seems to work. I'm checking all the buttons, all the LEDs. They seem to all be working. In fact, I've just pressed the reset button here to show you. And then all the LEDs came on. And pressing the enter, gets it all working. So next I got to take this to the system and check out the stepper motors and check out the limit switches and see if it all is working. Okay, I just finished getting most of the bugs out of the system after putting on the bandsaw on the Accu-Slice system. A few things need to be changing. Number one, the stepper motors were going in the reverse direction, so I had to reverse those on the software. That was just a software change. I was having trouble with the mag jigs. Those had to be adjusted. They were a little bit too high. They weren't hitting the table, so they're adjusted now, so they're working. I have a little bit of trouble with the Hall sensors, but they're adjusted now. They're working. That was just a wrong wire hookup, and that should be it. Everything seems to be working. I did calibrate the system, so it's calibrated now. So I'm running, right now I'm running at 20 inches per minute, so I'm running at 10 inches here. And let's go ahead and try the auto run. So the auto run will advance it as it's cutting through the board, reverse it, take the index forward for the next cut, repeat it, forward, backward, and then just keep repeating that. So let's do a total of 3 boards. So I press my button here, and I'm going to do 3 boards. It's telling me I need 0.30 inches of wood. So if I had wood mounted on here, which I don't, it's just a test. And so let's go ahead and run this now. So it's advancing at 20 inches per minute, which means it'll take 30 seconds to go. I got magnets on my carriage here. As soon as that gets near my Hall sensor, it'll sense it and then reverse it. Reverse it at a higher speed, of course. Another sensor back here stops it, and then it moves forward out of the range of that sensor, so the sensor is no longer active. And then it actually increased this indexing wheel. I need to put a delay in that. That's one step I got to make yet. Should be a little bit of delay between steps. think there's a few places in the software I want to put some delays. You know, even like here where it stops, rather than just go right back, I may put a stop in there. Because as soon as it hits that, it goes reverse right away. It actually be good to have a stop or a delay there. Advances the index wheel. And even there I could use the delay. You know, even like a 1 second delay, that's all I need. So I have a few software changes to make. At this time I have one more board to cut. I guess this is the last board it's cutting. This is the third board. And I did calibrate the speed in inches per minute. I also calibrated the index wheel so that everything's accurate now. The end here, it actually advances the index wheel, you know, for the next board, even though there's none there. And that's it, that worked perfect. Other things I can do with it, I can use my, I can of course activate my magnets manually, which is really no need to do that. I can run the indexer manually. And this reverses the indexer to get to the starting point. Okay. I can run it manually. And if I need to stop it, I can stop it. One thing I noticed, it will not stop when it's going in the reverse direction, when it's doing auto run. So I have to add that to the software too. So there's some additional changes to make in the software before this is perfected. So if I was running this, it would just go the whole way through until it hits the sensor and then reverse it automatically. That's another change I made to the software from the previous version. When it hits the end, it's going to go back to the beginning and then advance the index wheel also. So enable you to run in a semi-automated mode. And one thing you don't need to worry about is the magnet. See, the magnets are activated now? So there's no need to worry about opening and closing the magnets like you did when you're running it manually. Sometimes you forget to open or close the magnets and mess them up. And when it's done, it'll turn the magnets off. Magnets turned off, system's turned off. The indexer just is running right now, and that's turned off. So these lights just tell you when things are running. Reset will actually restart the program, and the stop button and the stop button are one and the same. Instead reset sets the whole system, starts over. Again, where you can just test all your LEDs, make sure they're all working. You adjust your thickness of board. So I set my board to 1/2 inch. And the reason I made 4 decimal places here because in the initial prototype I only had 3. And I was getting errors because if it was, 49 and a half, it would stay 5, and if it was 49 or 50.4, it would still stay 50. So to get more accurate, that's why I added the 4 digits, so it just gives you a little more accurate results. So it's pretty hard to get it exactly at 50, but it's better than it was done before. There is exactly 50,000 of an inch, and the blade kerf. So there, set that to 50,000th of an inch, right on. Forward speed, I had that at 20, I can go higher. In reality, I usually go lower, but let's set it for 30 inches per minute. And the reverse speed, I can go even faster, take it up to, increase that, it only goes up to 84, I've got to change that in the software too, it should go up to 100. I'm ready to cut my first set of boards using an automated system. And I have my system set up to cut some slices of boards 25,000 of an inch thick. My blade kerf is about 47,000th of an inch. My forward speed will be 10 inches per minute. I find that's the best speed for getting nice smooth cuts. And my reverse speed is 60 inches per minute. And I have about a 6-inch diameter segmented disc here. It's a scrap disc. It has some small cracks in it. I won't be using everything, but I wanted to test it. So I'll be cutting a bunch of pieces, say 25,000 of an inch thick. So let me first of all, I just set it up to cut my first piece off to give me a straight edge. So let me get that ready to go. Now first thing I did, I adjusted my stops, my beginning stop and my end stop. So I adjusted those. I adjusted my board to where I wanted it using my jog buttons to move it back and forth. You know, I can move it back and forth to where I need it. So my stops are set, my distance is set. I brought my indexing back to a starting position. And so let's just cut a single board at this point. So I first of all turn the bandsaw on and then push the run button on the Accu-Slice controller. Notice that when I push the start button, the green light on the run button lights up and the yellow light on the magnets lights up, indicating the magnets are activated. And this video is running at actual speed. I wanted to show you exactly how slow it is actually cutting. So this part of the video is not sped up, it's actual cutting speed. It'll start passing the board through the bandsaw blade. Now again, this is proceeding at 10 inches per minute, which is a very, very slow rate. I would never cut it manually at that slow. It would be just too tiring and just not very productive to cut that slow. But I found by cutting at 10 inches per minute, I got really nice cuts on the bandsaw. And then when the Hall sensor is activated, it reverses the board to take it back to the starting point. This reverse speed is a little bit slower. I'll speed this up in the future. Okay, we cut this scrap piece off and I got a really smooth surface. You know, cutting this thing with a 10 teeth per inch blade and cutting at 10 inches per minute, I get beautiful cuts on the bandsaw. So now let's run this in the automated mode. And for this first test, let's just run 3 pieces. So again, I'm setting my board thickness to 25 thousandths. My blade curve to 47 thousandths. My speed to 10 inches per minute. My reverse speed to around 60 inches per minute. So I press the auto run button. I'm cutting 3 boards. It tells me I need a 0.22 inches of wood, which I got plenty there to cut this. And now we're ready to start cutting. So we'll turn the bandsaw on first and we'll just start cutting. I press the enter button to start the process and notice the magnet LED and the run LED both go on. The carriage is starting to move through the bandsaw blade at the 10 inches per minute. And this once again is displayed at the actual cutting speed, so you can see how slow it is really cutting. And once again, I am cutting this at 10 inches per minute, and my blade is a 1/2 inch wide blade, 10 teeth per inch. Now I would never cut this slow by hand, it'd just be too time consuming and too tedious. But when it's automated, it's easy to cut at these slow speeds. And just based on experience, I know I get beautiful finishes that require no sanding whatsoever on the surfaces of the pieces of wood. And now the Hall sensor senses the end of the cut and reverses the board at a higher speed back to the starting point. The Hall sensor senses the starting position, turns off the magnets, and advances the index wheel. After the index wheel has been advanced, it turns the magnets back on and starts the next run. I'll now increase this video 10 times the actual speed so it doesn't take so long to watch the process. You could run your boards at a higher speed to reduce time, however you wouldn't get near as nice of finishes on your cuts. When the last piece has been cut, it does advance the index wheel for the next position and turns off all the LEDs. You just saw that was totally unattended. I got 3 discs off there, which should be around 25,000 of an inch thick. So let's actually measure them and see what they are. 25.5, 25.5, and 25.0. So within a half a thousandth, all 3 of those discs. And the surfaces on that are beautiful. Let me cut a couple more, and I'll change the angle of the camera so you can see from a different angle what it's going to look like. Once again, I'm cutting 3 boards 25,000 of an inch thick. After the carriage reverses, notice the index wheel advancing for the next cut. Okay, that was 3 more cut, totally unattended. Let's see what we got in thickness. I got 28 thousandths on that one. 25. And 28. Next, I'm cutting 7 slices off the segmented disc. Each slice will be 50 thousandths of an inch thick, and I'm using the same speed of 10 inches per minute. And again, this video is sped up for viewing purposes. And this is the final slice off the board. That was unattended except a couple times it hung up like here. All 7 discs measure between 50 and 51 thousandths inch thick. Well, that completes the initial testing of this automated Accu-Slice system. As I said, we cut 6 discs that were 25 thousandths inch thick, plus or minus 1.5 thousandths. And we cut 7 discs that were 50 thousandths of an inch thick, plus or minus 1 thousandth. They're really close. But the finishes on these are unbelievable. And that's 2 reasons for that. Number 1, I'm cutting with a 10 teeth per inch blade, which is a pretty fine blade. I'm cutting very slowly. And because I'm moving through her on a rail, no jerky motions, nice, smooth, even cuts. And those 3 factors all give you beautiful, beautiful finishes. I mean, I can't even see the blade marks on here at all. It looks like it was run through a sander. So it's that clean. So anyway, that completes this initial testing on the system. And this is probably the final video of this series of actually 8 videos now I've made on the design and production of this automated Accu-Slice system. I still have a few things to do on the system. There's a minor bug in the LCD display. It keeps bombing out every now and then. I don't know if that's a loose connection or a bad LCD, or could it be I had a couple delays in there, and the delay may have affected that, so I'll have to go ahead and check that out. And the maximum number of pieces I can cut right now is 7. I want to double that to maybe like 15. So I can cut 15 pieces at one time. So I do have some projects planned for this. I've been working on a series of trapezoid shaped segments, and I want to do a series on that. And one of the things I want to do is cutting layers off of those trapezoid shaped segments to make like what they call an Indian pattern or a Southwest pattern. And that'll be easy to do on here. The system works good enough I can trust it to accurately cut my pieces and just read it automatically and not have to worry about it. So again, this completes this series of the 8 videos on the design and development of the automated Accu-Slice system. We'll still be doing some tweaking, and I'll be demonstrating this, showing this some more in future videos. If you have any questions or concerns or comments on this automated system, please drop us an email or give me a call. I'll be happy to talk to you. And once again, thank you for watching this video.